This is chapter 5-2, bisectors of a triangle. Please copy your codes. To begin on this particular one, we're going to start with a perpendicular bisector. And a perpendicular bisector of a triangle can be a line, a ray, or a segment that is perpendicular to a side of a triangle at its midpoint. So for example, my blue line here is a perpendicular bisector. It evenly divides this bottom segment in half. Two things happen. It's perpendicular, forming two right angles, and it bisects both of the sides exactly in half. Now a perpendicular bisector, well, I'll leave that for later to go into further explanation. But the perpendicular bisector does two things again. It will take and divide the segment exactly in half at its midpoint and form two right angles, therefore being perpendicular bisector. When three or more lines or rays or segments intersect the same point, they are called concurrent. Lines, rays, or segment. Let me see if I got this on another with some better drawings on here. I do. So I'm going to use this one. When three or more lines, rays, or segments intersect in the same point, they are concurrent lines or concurrent rays or concurrent segments. Okay? The point of intersection of a line is called the point of concurrency. Okay, so here we have on this particular example, three perpendicular bisectors of a triangle are concurrent. The point of concurrency, it can be inside, outside, or on the triangle. If it's inside, like this one here, it's an acute triangle. If it's outside, it will be an obtuse triangle. If it's right triangle, the point of concurrency will be on the triangle. Well, what do we mean by point of concurrency? First of all, these are green lines. These three green lines are all perpendicular bisectors. What do I mean? For example, this first green line, remember what perpendicular bisector means. It divides this bottom segment exactly in half. So these two segments will be evenly divided, as well as two right angles will be formed. For this particular side here, this is the perpendicular bisector. Again, it divides this segment exactly in half, and it will form two right angles. Finally, my third perpendicular bisector is here. It's going to divide this segment exactly in half and form two right angles. Where will all three of the perpendicular bisector lines intersect, this one blue or purple point, it's purple actually, that purple point is called the point of concurrency. Okay? And because this triangle happens to be an acute triangle, the point of concurrency is actually, I drew a big dot there, it's actually in the center of the triangle. Again, point of concurrency is when I draw three perpendicular bisectors, that one point or place that all three intersect is called the point of concurrency. Now, here's my second type of point of concurrency. I have a right triangle, and as I stated, on a right triangle, the point of concurrency, point P, my point P here, and that's my point P up there, point P lies on the triangle on a right triangle. So here again, here's my first, this was a line bisector, it's a perpendicular bisector. I have two right angles, and again, these two segments will be congruent. Here's my second line, this green line here. Doesn't need to necessarily go, perpendicular bisectors do not necessarily need to go through an angle. They don't have to go through an angle. This was just rather close. But this second green perpendicular bisector again forms two right angles. And these two segments are congruent. And then the third one is here. Here's my perpendicular lines and my two congruent segments. Okay, but again on the right triangle, the three places, or the one place, excuse me, that the three perpendicular bisectors intersect is called the point of concurrency, and on the right triangle, it will be on the triangle. Finally, on an obtuse triangle, my perpendicular bisector, the one place of concurrency, that one point, is going to be on the outside of the triangle. So here's my first bisector. Okay, and that means that these two segments are congruent. Here's my bisector here for this one. Again, congruent on both sides at the midpoint. And then finally the third one, that means that these are congruent. Okay? Next we have a point of concurrency of a perpendicular bisectors of a triangle is called a circumcenter of a triangle. And I'll show you what I mean in just a minute. Point P on these particular one, the green lines are my perpendicular bisectors, and I'm going to slide this just a little bit. You should be able to see the top. Point P is the circumcenter of three triangles, the three triangles we just drew, and the one we're getting ready to look at right now. Here's theorem 5.5, which talks about concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices. Well, what does that all mean? Let's back up just a little bit. Quickly reviewing, looking at the three perpendicular bisectors. I didn't draw them all the way down, but you can see this first green perpendicular bisector bisects line segment AB. Gives two right angles, and both the segments are congruent. Here's my next perpendicular bisector for AC. Okay, AC is bisected in half with two right angles there. And then there's my third perpendicular bisector here for BC. Well, that one place where all three, as we talked about, all three perpendicular bisectors intersect right here at point P is called the point of concurrency. Well, when I draw my point P in, my point of concurrency right there in the center, if I go from my point of concurrency and draw to the vertices out, that's these blue lines, if I go again from the point of concurrency and draw out to each vertex, I'm going to have what we call, again, the circumcenter of a triangle. What that means is I could come, if I were to draw a circle, excuse me. Just imagine I had a nice round circle here. And it's some kind of other shape, but anyway, if it were a perfect circle, it will be nice and even on all sides. That means that if this is the case, after I draw my point P, or concurrency point, and I draw from point P over to each of my vertices, that means that the length from P to A is going to be equal to P to B, and the length of P to C. All three of these segments will be equal. I drew, again, from my point of concurrency to my vertex, or vertices, I should say. That means that all three of my line segments will be congruent. PA is congruent or equal to PB and PC. Right? And this is theorem 5-5. Finally, angle bisectors. Angle bisectors are much easier. Okay? All those are as you draw from the angle outward. Remember, angle bisector means you divide the angle or bisect it exactly in half. So if I come from here out, I've bisected this angle into two congruent pieces. Shoot, out there. If I draw this right here, out, and I bisect it, that means both of these angles are congruent. And then on my third angle, excuse me, on my triangle, if I draw the right here, out and bisect it in half, all three of the either lines, segments, or in this particular case, all three of my rays intersect at one particular place. Right here at point P, and it's called the intercenter of a triangle when I call myself bisecting angles. This time, it does not mean now, when I do an intercenter of a triangle, that does not mean that these two segments are congruent. That's not the same. That was perpendicular bisector. On this one, what I'm saying is now the two angles are congruent when I bisected it in half. And when I do that for all three of the angles, the one place where they intersect is called point, well in this case it's called point P. But what that means is that I have an intercenter of the triangle. And an angle bisector again can be used in a triangle. The point of intersection has three angle bisectors called, as I stated, the intercenter of the triangle. Here's theorem 5-6. And this is our last theorem. It's concurrency of an angle bisector of a triangle. Okay, and that means the angle bisectors of a triangle intersect at a point that is equidistant from the side of the triangle. Okay, so here I drew it. My angle, the blue are my angle bisectors. If I were to extend it out and keep going. Okay, so here's my first angle bisector. That means that these two angles are congruent. Here's my second angle bisector. It will go out here somewhere. But I just cut it off. So if I were to draw this segment here, this blue one, these two angles are congruent. And then my third angle bisector is here, this blue line. And again, I just didn't draw it all the way out. If I were to draw it all the way out, it would be over here somewhere like that. But I just cut them off. Well, anyhow, this angle bisector states that these two angles are congruent. Remember, the one place where all three of the angle bisectors intersect is the intercenter of the circle, and I call that one point P. So this point P is here. If I go from point P and draw a perpendicular line to this segment, boom, like that, and I come over to this segment and do the same thing from point P. If I find a perpendicular line, boom, and I draw it like so, and I come here and draw a perpendicular line there, that means when I draw the perpendicular lines, all three of these newly drawn green perpendicular lines that were drawn from point P, or the intercenter, that means that all three of my lines will be congruent. All three of my newly drawn perpendicular lines from the intercenter will be congruent. Okay. And I could also draw circle on my circle inside on this one as well. And I'm going to pause here.